Good evening. So this is lecture number 16. We're going to be talking about using US Census data with GIS. And this will morph into a discussion about doing your lab number 7. So let's go ahead and have you, if you haven't already, download lab number 7 to your computer and unzip the Lab 7 folder to your GIS 3043 folder, either at home or there in the classroom or on UCF apps if you're using that. So let me give you all a minute to do that, and then we'll go ahead and start the lecture. Let's talk about where the US Census comes from. It's actually mentioned in the Constitution. It's actually one of the first things that the Constitution talks about in Article 1, Section 2, where it describes the makeup of the House of Representatives. The idea was to have House districts sized in such a way that each one would represent the same number of people. So in order to be able to accomplish that, there needs to be a census to determine how many people live in each state and where are they, so that a district can be created around for each congressional representative that has essentially the same number of people as all the others, to provide equal representation. Now, the language here is a little unusual, because you have to remember in 1787 they had to deal with issues that would seem strange to us today. For example, Indians not taxed. So in other words, any Indian Native Americans that were represented in a state who weren't taxed, in other words, weren't essentially getting government services, weren't included as citizens for the purposes of representation. And also those bound to service for a term of years, and that also included slaves, would be represented as 3/5 of a person. All right, so we obviously don't have those problems today. But the key thing here is that an actual enumeration will be made within 3 years after the first meeting of the Congress of the United States, and within every subsequent term of 10 years. So the first U.S. Congress under the new Constitution was in 1790, and then or at least the first census after the Congress was established was in 1790, and then it was done every 10 years. So it's always the decennial census always falls on a round number 10. So we just had the last one in 2020. So the census is required every 10 years. Its primary purpose is congressional reapportionment. There's a public law called Public Law 94-171 established by Congress, which lays out the requirements for congressional redistricting and spells out what the Census Bureau needs to do in order to support that. And the census itself is conducted by an arm of the government known as the US Census Bureau, and you can click on that link to find out more about the Census Bureau. So let's talk a little bit about the process of redistricting. So that was done after the 2020 census. In every state and local government in the country went through a process of redistricting. So we have to, the Congress requires that we change the districts for members of Congress, representatives in Congress, in the House of Representatives. But cities and counties also use this, as an opportunity to redistrict city and county commission districts. So here is the example of the redistricting process that was done in Orange County in 2021. And you can click on it to actually go out to the web page if you want to explore it more. So this is a good example of how at least the more progressive, in other words, more sophisticated counties. Now, if you were a little tiny county out in the middle of nowhere, your redistricting might have been done with a spreadsheet and a paper map, on the wall. But all the more sophisticated counties, the big ones, tended to have a process that looked very much like this, and they used GIS quite a bit in working out what their redistricting ought to be. So here is a proposal. You can see here it's number 13 for doing the redistricting. So, what they had to do was redraw the lines and then determine first, is there roughly the same number of people, plus or minus, a certain amount within each district? That's the most important thing. And then they looked at, the distribution of people by race and other factors to ensure that, we've got equitable distribution based on those factors as well. So here is the tabular data that was generated for, in this case, proposal number 13. And you can see it's got, how many people in each district, 1 through 6, what the total population would be, and it's very hard to get it to be exactly equivalent because, you've got like say a housing subdivision, and, you either include it in District 1 or District 5. You don't want to split it so that people on opposite sides of the road in the same subdivision are voting in different, or represented by different county commissioners. So, it's kind of hard to make it turn out exactly even, but there's an amount that they allow plus or minus for doing this. And you can see that it's got, here's the deviation from equality in terms of number of people and the number of whites, blacks, American Indians, Asians, and so on that are represented using the census data to determine that. Okay, so that's a good example of how GIS was used to help establish equitable districts, and that's what we would ideally want is to have districts that are fairly representing everybody, all the voters. In other words, voters should be picking their representatives. We shouldn't have our representatives picking the voters. That is called gerrymandering. When there's a situation where the people in charge of doing the redistricting essentially craft the districts to ensure that they get reelected and other members of the ruling party get reelected, they're basically using their power to alter the way that you and I can vote and select representatives, because they're making it harder to select people from the other party. So here's a good example of that from Texas. You can see here this district number 2 has this extremely weird shape. An odd shape is usually a dead giveaway that there's been gerrymandering applied to the redistricting. In fact, the name gerrymander comes from when a politician, I think in Massachusetts, named Jerry, was involved in manipulating the districts in his state. It created a bunch of these salamander-shaped districts, and people, journalists writing in newspaper articles, refer to them as gerrymanders, like Jerry salamanders, hence the name. I think that's called a portmanteau when you take two words and mush them together like that. Anyway, so you've got this very odd salamander-shaped district here. So why is it shaped like that? Well, if you look at the racial distribution around Houston, you can see that, here in the middle of downtown Houston, you have a large number of Black and Hispanic areas, but in the periphery, around the outside, the suburban areas around Houston are largely white people. Not everywhere. Here's some, Hispanic folks here, but mostly white people living in this area here. So by making District 2 shaped that way, that ensured that all of these people likely based on using race as a proxy for how do they tend to vote, they're all going to tend to vote for the current party in power, which in this case would be the Republicans. So a good case in point of what not to do in terms of redistricting. There's a announcement that just got posted automatically that has a lot more about redistricting, and it has some good articles in it about redistricting, as well as some links to some articles about court cases. There were two court cases, one on gerrymandering in North Carolina and Maryland, and another one on Michigan, that in some cases they struck down gerrymandering. In other cases, they allowed it. One of the things that the Supreme Court has allowed, which is a little disappointing, is that if a gerrymander looks like it was based on politics and not on race or some other protected class of individuals, Supreme Court's okay with that. So they don't mind you manipulating the districts unfairly if it's just to favor one party over another, as long as it's not a racial gerrymander. So who can understand that? There are states that have done things in order to try to address this problem and solved it. Florida attempted to solve this by a constitutional amendment. I think it was adopted in 2010 that laid out some ground rules for redistricting. It said that districts needed to be compact and contiguous, so you can't have salamander-shaped districts. And there's been lawsuits to eliminate those kind of districts, and they were found unconstitutional, and they had to be redrawn. But they have to be compact and contiguous, and as much as possible, they have to follow existing either geographic or political boundaries. So you want to follow the river, or you want to follow the county boundary. You don't want to be jumping across the county boundary just to pick up a group of white people or a group of black people on the other side of the boundary to make it part of your district. So that was intended to try to eliminate gerrymandering in Florida. It's only been partially successful because in order to be implemented, it requires that somebody files suit against the state when there's a suspected gerrymander. So it's not self-executing. Somebody has to look at the results and say, hey, that looks like a gerrymander, and then take them to court. If the courts determine it is a gerrymander, then it has to be redrawn. But it does lay out some ground rules for the legislature. And in fact, since then, in 2020, they did follow the rules. Then the governor stepped in and said, I don't like, even though you guys voted on the districts and both the House and Senate voted on them and were completely fine with them, I don't like them, and I'm going to force you to come back and redraw them my way. And, there you go. So, unless you can defeat that in court, those districts were stuck with those. In California and some other states, they've gone about it a different way. They've had a nonpartisan commission of not elected officials, a nonpartisan commission of civilians does the redistricting. So they, very much like the way Orange County, they've got all the data, they've got the rules, and then they figure out the redistricting. But they're not party representatives; they're just trying to figure out the best way to split up the state. California's been doing this, I think, now for 20 years, and everybody's happy with it. Everybody says, that's fine; it works great. And there's a few other states that have done something similar, where they've got a nonpartisan or bipartisan commission to do the districts. So it is possible to solve this problem. I think Michigan is one of those that there was a citizen initiative to establish a nonpartisan commission, and they were successful. They got it on the ballot, were successful, and now it's done that way. All right, so let's talk more about how the US Census data is implemented using GIS. First, this word, TIGER, Topologically Integrated Geographic Encoding and Referencing System. I'm pretty sure that they came up with the acronym first, TIGER, and then they came up with the words to support it later. But this is basically a long way of saying this is the name of the GIS data file system that is used by the Census Bureau. Now, the Tiger actually is not natively in the software that we use. It's not in Esri ArcGIS. It's, the census had its own proprietary way of dealing with the data. So in order to get data out from the Census Bureau into a format that we can use in Esri ArcGIS is actually a little difficult. But this is the name of the format, Tiger. And Tiger actually has like two big components. It's got all the geographic information, the lines, points, and polygons that make up things like roads, rivers, lakes, places, things like cities, landmarks, things like airports, military bases. So all of those are the base map layers. And so those are all part of what are known as the Tiger line files. In other words, the Tiger geography files. Then there's also what's known as census geography. Census geography is the units of the landscape that are the ones for which the Census Bureau is collecting data. So at the very smallest, that is known as a census block. And you can think of it as being like a city block. It's not necessarily exactly a city block. It might be bigger. But you can think of it as being like, if you walk down the street, and get to an intersection, you go around 4 times, and that's a block. That'd be the smallest census unit in the census data. And then we have what are known as block groups, which are assemblages of blocks. Block groups are put together to form census tracts. And then census tracts go together to make up a county. And of course, counties make up states. The tabular data that goes with the census geography, that is the data that's supplied as a part of the Public Law 94-1 and some of the other data files. That's all provided separately by the Census Bureau, and you have to join those up with your census geography later. To understand how the census data are organized, you have to understand something called the FIPS code system. That's down here at the bottom, the Federal Information Processing Standard, FIPS codes. So here is a FIPS code that is for one of the counties in Florida. So the first 2 digits of the FIPS code stand for the state. In this case, Florida is county number 12. You might not be surprised to learn that county number 01 is Alabama and county number 13 is Georgia. So it's alphabetical, and then each of the states is numbered. The next 3 digits represent the county. So county number 95 is Orange. Now let me pause here. How many counties are in Florida? Who knows? Anyone? It's 67. All right. There's 67 counties in Florida. So why is it that Orange County, which is only midway, if you started with Alachua County is number 1, and the last county is like, Washington County, that's 67 counties. How is it that Orange County, which is sort of in the middle of the list, how is it county number 95? Okay, there are other Orange counties, says Thomas. Well, that is true. There are other Orange counties in other states. And that's why the first 2 digits represent the state. So if you had Orange County, New York, there'd be a different 2-digit signifier for New York. And then, they would have a number for the county. So that's true, but not the reason why it's 095 in the state of Florida. All right. Well, think about this. Where do counties come from? Counties are a division of the state. So the state can, states are essentially units of the United States federal government, but the federal government has nothing to do with counties. That's an artifice of the state. The state can make counties however they want. And it could be on any given Tuesday that the state decides to actually, subdivide a county into more counties. If we look at maps of Florida, for example, so here's a map of the state of Florida. Notice Orange County includes what is now known as Seminole and Lake. There is no Lake County. All right. So what is Lake County today was used to be part of Marion, Sumter, and Orange County, and Seminole County didn't exist. And Volusia County went all the way down to the Indian River line, whereas now this is Brevard, which again didn't exist in the date of this map. I forget what date this is. This is in the 1800s. So at any given moment, the legislature could subdivide a county, and make more counties. So the Census Bureau has provided room for numbering additional counties as necessary by not making them sequential. So there's space between county number 95 and the previous county. There's several numbers that aren't being used to make room for possible additional counties. The next code group is 0105. So these 4 digits stand for the census tract within a county. So a county is divided up into census tracts. So 0105, also sometimes written as 105 with 2 zeros, would be a census tract. The next 3 digits, 002, would be the census block group inside of a census tract. And then finally, you've got 011 is the census block within the block group, sometimes written with the block group number appended to the front of it to call it 201. So these conventions, you don't have to worry about them in GIS. This is just how people sometimes referred in writing. You know, they might write about census tract number 010500, or they might, have in a document, it might say, census block group number 105002. That's not the way we refer to it in GIS. That's just the way people might refer to it in a written document. So this is something you're going to need to know how to work with. You're going to need to know how to decode one of these numbers. So if I asked you, like, what is the census tract from this string, you'd have to know it's this right here, 105. Okay. You don't need to know, like, for example, if I asked you what county it was, you'd need to know it was county number 95. I don't want you to give me the name. I just want you to give me the number if you were asked that on an exam. There are ways to look this up. There is a list, and it's available in your module, of all the FIPS codes for the whole state, or the whole country rather. And you can look up, what are the county names for each of the county FIPS codes by state and county number. All right, so let's talk more about how these look in terms of the actual geography in the real world. So county number 1295 is Orange County. So, it looks like this. It's the whole county. The county is in turn broken into census tracts. So here's all the census tracts in Orange County as of, this was 2000. So I don't have the ones for 2020, but they don't look a whole lot different. Notice that census tracts are not all the same size. We have a bunch of little tiny ones here and some really big, huge ones out here and out here. So why are they so different in size? Yeah, the whole idea behind the census geography is to have roughly the same number of people in each one. So if you're going to assemble districts out of census tracts, if they all have roughly the same number of people, when you put 10 of them together and you put 10 of them together over here, they all have, the same number of people. So yes, they're sized so as to have roughly the same number of people in each census tract. So places that are very dense, like downtown Orlando, the census tract is small. Out in the middle of nowhere, like out here on the way to Cocoa, there's not many people living out there. Census tracts have to be very large to have the same number of people. All right, thank you. So we've zoomed in on what the census tracts look like in downtown Orlando. So you can see here, there's census tract number 105 that we were talking about, and he's surrounded by 106 and some others. And you can see the boundaries here, and they're not rectangular. They have these kind of odd shapes, and you might be wondering, well, why are they shaped the way they are? Well, they follow things like roads. So this is the 408, and this is I-4. Or they follow geographic boundaries like water bodies, like this one goes around Clear Lake. Okay. So this is another road. This is Orange Blossom Trail going this way. This is Highway 50 going this way. So they follow roads, railroads, rivers, lake boundaries. They do not follow things like city and county boundaries. So again, any thoughts as to why? Okay, imagine yourself as a census worker. You're told out to go out and that you need to collect, you need to knock on doors and collect all the data from people who have not yet responded in census tract number 118. Now, I can assign you census tract number 118 because I can give it to you, and on a map you can see, okay, I need to go up to Highway 50 and stop, and then I need to go over to whatever this road is. I think that's John Young Parkway and stop, and then I need to go down to the 408 and stop, and then I need to take the 408 over to Orange Blossom Trail and stop. I'm not supposed to cross those roads. My assignment is inside those areas. So since the boundary is all roads that I can see, it's very easy for me as a field worker to actually tell where my boundary limits are because those are geographic features that are in the real world. If I told you, hey, the northern boundary of census tract number 118 is the Orlando city boundary, where's that? Who knows where that is? Have any of you ever driven on the road, and other than occasionally a sign that says now entering the city of Winter Park, have any of you ever been aware of where the city boundary is for a city? Oh, okay. So if you were to walk, yeah, Darla, if you were to just walk cross country, you would recognize when you crossed from Orange into Seminole County? No, there's no lines drawn on the ground. There's not a dotted line on the ground. You might see a sign occasionally, but you could drive between UCF and Oviedo, and I don't think that there's even a sign that says now entering Seminole County. There'd be no indication that you've just crossed from one county to the other than the design of the road signs would subtly change. But there's no line on the ground. There's no signage. So it's very hard to tell where you are from political boundaries.
She said there's a sign.
Yeah, okay. But that's rare. There's a lot of roads that go between counties or between, it's more often that you'll see on something like an interstate, there'll be a sign that says now entering Orange County. But usually local roads, there's no signage. You just cross over from one to the other. There's no indication at all. And if you're not on a road, there is definitely nothing to look at. I think McCulloch Boulevard is the boundary between Seminole and Orange. If I walk across the street, there's nothing. There's not a stripe in the middle of the road that says now entering Seminole County. There's nothing. Okay. I can walk back and forth all day and there's nothing to tell me that I've walked between one county and the other. This is usually the case, is when you're outdoors, county, city, state boundaries, there's nothing visible to tell you where you're at. Whereas roads, rivers, railroads, everybody can see those. Those are a great way to delineate a boundary because you can see them when you're outdoors. All right, so here's block groups. So you can see here our census tract number 105 is broken into two block groups, number 1 and number 2. And when I blow that up, I can see that block group number 1 and block group number 2 are each broken up into individual blocks, and they're all numbered here with their prefix 1 or 2, and that's block number 6 and block number 7 and so on. Okay. And again, those are all following boundaries on the ground, mostly local streets. Some of them are very large because there's very few people living there. This is sort of a residential area that's sort of also got a lot of industrial uses. So this might be like a big warehouse or something here with only a few homes right on the road, but behind it is a big warehouse or other industrial activity. So there's not very many people living in census block number 25. Whereas here, this is an apartment complex, so there's a lot of people living in block number 11, so consequently it's really small. There's other kinds of boundaries that are available in the census geography. There's one that's very useful called the Census Designated Place, or CDP. So here you can click on this link to find out more about CDPs. That they are, sometimes people are tempted to think of these as being cities. Don't be fooled. Cities are included in the CDPs, but that not everything that is a CDP is a city. So everything that is a city is a CDP, but the reverse is not true. You have areas that are recognized by the local inhabitants as being a place. They've given it a name, like Bithlo. You know, how many people have ever talked to people who either live in Bithlo or, you know, they've been to Bithlo or they're driving to Bithlo? And okay, some of you are familiar with Bithlo. Bithlo is not a city. Fun fact, it used to be a city and it fell apart. Basically, it wasn't able to sustain itself, and it lost its charter as a city and got absorbed into Orange County. So it's no longer a city. But things like Christmas was never a city. Wedgefield is a subdivision, was never a city. But people talk about, hey, I'm from Wedgefield. I'm going to Wedgefield. You know, there's a lot of houses available for sale in Wedgefield. It's a place that people recognize. And the Census Bureau has to go out and say, okay, to the people in Wedgefield, where would you say the boundary of Wedgefield is? And the people in Bithlo, where would you say the boundary of Bithlo is? And then they use that information to define that census designated place. So here, for example, is the census designated place boundary for Bithlo. And you'll notice it follows roads and then this river and then back to this road again. So here it is following the river. Okay. So this is a place that the Postal Service, the people who live there, you know, people generally recognize, yeah, that's in Bithlo, that's not in Bithlo. And then the Census Bureau ends up drawing a boundary as a result. So if you want to use this layer, the census designated places, you have to recognize that not all of them are cities. So it can be a little confusing. There's another useful layer called the urban area. And it looked in 2000 like this. We'll look at later what it looks like today. Well, actually, I take that back. The one we have in the census data is also the one from 2000. And you would think, like, hey, this would be a good way to look at something like urban sprawl, right? Because, you know, if I looked at the one from 1970, it ought to be this big, and 80 would be that big, and 90 would be that big, and 2000, you know, we get bigger and bigger and bigger. And that's would be a good way to look at urban sprawl. You would think so. Turns out it's not that easy, because the definition of what should be in the urban area is something that is dictated by Congress. And if Congress changes the definition, the line might actually change. Sometimes urban areas will shrink because Congress has said, well, you know, we're giving money to urban areas for water, wastewater projects, or for roadway projects, or for other kind of housing projects. And we want to redefine what constitutes an urban area, because we're giving too much money to places that aren't really urban areas. And if they do that, the urban area might actually shrink. So you can, for any given time horizon, like a given, you know, year, like 1990 or 2020, you can use the urban area as a way of distinguishing urban from rural, but it's not something you can necessarily look at over time because of that problem that it gets redefined every once in a while. All right, so let's talk about the demographic data. Those are the geography boundaries that we're going to use in GIS. How about the actual tabular data? Where's that come from, and what's that like? So I mentioned this earlier, this Public Law 94-171. It's always, that data set is always the first one released after the census is done. And it includes the number of people who are 18 years or older by their Hispanic origin. And that's it. That's the only information that's in that data set. And that's because that's the data that's being used for the congressional redistricting. And by race and Hispanic origin. not just Hispanic origin. So under the US Constitution and the Civil Rights Acts of 1964, 65, these are the things that need to be taken into account when you're doing redistricting. Everybody that's over voting age, 18 or older, and race and Hispanic origin. After the redistricting data is released and everybody's working on redistricting, the Census Bureau goes back and they start developing other kinds of data sets that are of interest to people for other reasons. So they've got this thing called summary file number 1, which is family data. It includes for each unit, block group, census tract, county, the age, sex, households, families, race, and housing at those levels. Later comes SF2, which is more detailed and may include a lot of cross-tabulation data, like between, age versus sex and age versus race and that sort of thing. And it's similar to SF1. It's just a lot more of it. But it's not available for anything that has less than 100 people. And you'll see later, when we look at the data, there'll be census block groups that are redacted, that don't exist in the data because they had too few people in them. And the reason being, if there's too few people in a given block or block group, it would be possible perhaps to figure out from the census data that, oh, that's the information for that particular family, and that would violate their privacy. Say, for example, you had a block that only had one Hispanic family in it, the Mendez family, and then you saw in the data this Hispanic family has, and then you've got all their statistics. Well, I know that that's them because there's only one such family in that block. That would reveal them, in a way that would violate their privacy. So that data tends to be redacted. This is important to you as a GIS practitioner because when you're trying to do socio-demographic analysis, how many of you are familiar with the concept of environmental justice? Okay, fewer hands than I expected. All right, a few of you at home. Okay, so environmental justice, the term was around for a while, but it was established as a federal prerogative by President Clinton. He wrote a executive order that said all federal environmental impact statements must take environmental justice into account. They must determine whether or not the federal action that's going to use federal money adversely impacts people of color, minorities, Hispanic origin, adversely impacts minorities or people in poverty in a way that's both adverse and disproportionate to the general population. So if you have a new road coming through and it impacts minorities and Hispanic people, but it impacts them at about the same rate as white people, no problem. It's not an EJ problem. But if the new road comes through and it turns out poor people or minorities are impacted a lot more than the white people are, then that's obviously a disproportionate impact, and it would be an environmental justice violation. Well, consequently, people like me that were having to do environmental impact assessments of various kinds for various kinds of projects, we had to do an analysis looking at population by race and poverty status to determine whether or not there were adverse disproportionate impacts. You can't do that effectively with block data because if you've got an area where there's a lot of data is redacted, all the data is missing, you can't use it. So you often have to work at the block group level because that data is not redacted, and you can work with that. In my case, I had a project where we were looking at the environmental impact of a railroad merger. It was actually taking an old railroad that was going out of business and it was being split up between two other railroads. And but as a result, there was going to be a lot more rail traffic on some lines that used to be really, had very little traffic. Suddenly they were going to have 40 trains a day where they used to have 2. So there's a lot of environmental impact, noise and whatever. And we had to determine, was that causing any EJ violations? We first looked at using block data and we couldn't do it because the areas right next to the railroad were so unpopular. Not very many people lived there. So it was always redacted. So we had to go out to the block group, the next biggest unit, and do the analysis at the block group level. SF3 is where you get socioeconomic and income data. And then SF4 is other kinds of data that is the result of statistical sampling, not a full count. This is something, let me reiterate. Remember that the census is an enumeration by law. It has to be an actual count. It cannot be a poll. It cannot be an estimate. It cannot be a statistical projection. It has to be an actual count of the people on the ground. So SF4 is not based on counts. It's based on a sample. The most popular data tend to be PL 94171, SF1, and SF3. These other two are also used, but those are the ones that people are very excited about when they first come out. Now, as to that issue of counts versus statistical sampling, the Census Bureau has gone to Congress several times and said, we think we could do the census by just doing statistical sampling. We think we could get a really good result. And the Congress says there's no way. You have to do an actual count of the actual number of people per the Constitution. We're not going to do an amendment to allow you to do a statistical sample. But then Congress also was requiring the census to collect all this information about things that weren't related to redistricting. Things like, do you have running water in your house? And do you have a toilet in your house? And do you have a car? And how far do you drive to work every day? And these things were important for all these different federal programs. But it made the census form enormously long, and it made it very hard to get people to fill it out. The census came up with kind of a brilliant idea. They said, you know what? Why don't we do this? Why don't we limit the actual census to the things required by the Constitution, age, race, gender, and why don't we do all that other stuff the Congress wants, about running water and toilets and whether or not you own a car, and put those in a survey. There's no requirement to make that an actual enumeration. That's where we can use statistical sampling. So they call that the Census American Community Survey, or ACS. So you can go here to this website and learn more about the ACS. So there's a lot of advantages to doing this. Not only can the Census Bureau get all that additional data removed from the census and make the census easier to fill out, so you get better compliance on that, but you can do this sucker several times during the decade. So you don't have to wait every 10 years. You can be doing samples and getting updates of the American Community Survey at various times during the 10 years. And you can make certain surveys particular to, like, well, what if we want to just focus on transportation, or what if we want to just focus on water supply, or whatever they want to focus on, and they can just have questions related to those things in particular. So there's some issues when you're trying to use census data with GIS that you need to be aware of. These are things that can really trip you up. If you don't do this properly, you can end up with nonsense information. One is normalizing your data either per area or per capita. Now, we've already done some of this in practice, but let's talk more about why this is an issue. One way to normalize your data is to take the counts that you get. Like here, we have the number of Hispanic people, all right? So this is actually the neighborhood where I grew up. This is Eastern Orlando. So this is downtown Orlando here. This is the 408 going out here to UCF. It's about there. So this is the number of Hispanic people in each of these census block groups. So you can see very few Hispanic people here, lots of Hispanic people for some reason right there and there and there, quite a few in through here. All right. That's the count, the actual number of Hispanic people living on the ground. That's not really a good indication, though, of the relative amount of Hispanics, because as we've talked about earlier, some of these census block groups are bigger than others because they don't have as many people. So you might have a really big census block group. It gives you this big area that's all colored dark. You go, whoa, there's a bunch of Hispanic people there. Yeah, but it's a big area, and it's got a fair number of Hispanics in it. But when you look at how many Hispanics there are per unit area, like per square mile, might not be that impressive. If you look at normalizing by area, you divide the number of Hispanics by the area of the people living there, you get a much different map. Another way to do that normalization is to divide the count by the total number of people. So that way you don't get the number of Hispanics per square mile, which is kind of a weird number. Instead, you get the percent Hispanics, which is really kind of the way you experience, uh, you know, uh, uh, different racial groups in your environment. Like if you were walking down the street, as a, say as a black person, you're walking through, the UCF campus, there's not all that many people that look like you. But if you were in downtown Orlando, there'd be a lot of people that look like you. So the percentage of people that are black in a given setting is a pretty good indication of the racial makeup of the area. So you can see here at the bottom, we've divided through the number of Hispanics by the total number of people, and we get a different map. Look, over here, there were very few Hispanics as a count, but as the proportion of Hispanics, it's actually pretty high right there, or over here, okay? Whereas this area, that was looking like, yay, that's, really, really high in terms of the numbers of Hispanics. If you look at it as a proportion, number of Hispanics divided through by the total population, so it's now percent Hispanics, oh, that's actually not as high, as we thought, okay? So normalizing by area or as a percentage, normalizing by the total population is a good way to um, uh, eliminate misunderstandings about the way people are distributed, because it eliminates this business of the units being different sized and therefore having more or fewer people in them just because they're bigger or smaller. And it also gives you a better indication of how frequently do you run into people of, that persuasion, whether it's, you're talking about race, you're talking about gender, whatever it is you're talking about, income, how often do you run into them, on the street? Another thing you need to worry about when you're working with census data is if you do anything that changes the geometry, like if you have to clip an area, or you use intersect, which is effectively like clipping, or you use union, which is, again, you might think of it as a kind of a changing the geometry where you've now got different sized units than you started with. You're no longer taking into account the number of people that are in that new unit. When you clip, remember, when you clip a data set, it ends up with exactly the same attributes as the original data set. So if I looked at this situation, say I thought there was going to be a bomb that was going to go off in downtown Orlando and that it was going to affect all the people inside this red circle. You can see there's 1,766 people in this block group, but only this part is being affected. Well, if I was to clip this out, this part right here would still say 1,766 because the data, retains its, the original amount that was in the original data set. So the clip is going to have the wrong number in it. What you need to do is adjust for the fact that I've got a smaller amount of area and therefore a smaller proportion of the people in there. Now, in order to be able to do that, I have to make an assumption. So say we had an area like this, and can you rest of you not play on my whiteboard, please? And if I have a unit like this, all right, folks, really, I'm trying to do something here, and you're making it distracting by playing with my whiteboard. If I have a unit like this, and I want to look at, perhaps just those people that fall within this boundary here. So I'm only interested in how many people are in here. All right. There are two ways I can assume the number of individuals that were in this block to start with. One is I can assume that they are all uniformly distributed. So if the people in there are basically pretty well spread out uniformly, you know, at fixed intervals across the landscape, then the number of people in here would be proportional to the area that's in there. All right, all well and good. There's another way I can think about this. If I had an area like this, and I'm interested in determining how many people are inside, this boundary. If I had, instead of uniform distribution of people, if I had a random distribution of people, the number of people in this area would be proportional to the area inside that area, inside that section. So either way, if I assume either a uniform or random distribution of people, I can make this simplifying assumption and say the number of people that is in that little subset is proportional to the size of that subset. Now, the reality is people are neither, in most cases, either uniformly or randomly distributed. But we have to make this simplifying assumption in order to be able to make any kind of calculation at all, unless we're willing to actually go out and figure out where does everyone live. You exactly assign the number of people to each building, in the area of interest. Usually we're not interested in that level of detail. In most cases, assuming the uniformity of the distribution gets us pretty close to the right answer. So with that said, let's go ahead and look at this example of the bomb explosion to see how you would go about doing that. So you can follow along if you want to, or you can just watch. You don't have to do this. I would suggest to you that if you don't do it now, that you do it some other time so that you get a good understanding of how this works. But it's not required for Lab 7, so you don't have to do it. You may just want to watch me do it. So let me bring over ArcGIS Pro. And I'm going to go to the bomb impact map. All right, so this is the census block group data, and these numbers are the number of people in each census block group. So there's 1,766 people in here. Here's where our simulated bomb is going to go off, and this is the area where we expect everybody to be killed or injured. And I would like to know how many people are going to be affected. It's a dirty bomb, say. And that's all the people are going to be hit with, radioactive cobalt or something. So I need to know how many people are inside this part of that block group and inside of this part of that block group. All right, so here's the process, the general process for doing this. And it's the same no matter what you're doing. Anytime you involve any kind of clip or intersect of your data, anything that changes the geometry, you would go about doing it this way. So I would first go to the attribute table for my block groups. And I would add new fields. I would add a field called area old. And it is a floating point value. And it's going to have, okay, why does it not want to do that? Oh, there it is. Okay, it's floating over there. And it's going to have a numeric format. All right. So I have an area old field. I'm going to add another field called area new that is also a floating point. And then I'm going to create another field called ratio that is also a floating point. And finally, I'm going to create a new field to hold the population inside of each block group that's affected by the bomb. So let me call that the population per bomb. And that is also going to be a floating point value. All right, so let's add those fields to click Save. All right, so now that I've done that, I can actually go about clipping out the census block groups by this bomb impact area. So let me do that. Analysis. Tools. Clip. So the thing I'm clipping is the census block groups. The thing I'm using to clip it with is the bomb radius. And I'm going to call the output. I'm going to send that rather than to the default location. I have under databases, I have an explosion geodatabase, and I'm going to call that bomb population as my output. Okay, so when I run that, I get this new layer. See that? It's just the census block groups that are inside that bomb radius. But right now, it's still showing, I'm still using the old population value. It still thinks that the population there is 1766. Not right. So let's open up this attribute table. If I scroll way over to the right, oh, you know what? Let me back up. I forgot to do, there's an important step I should have done before I did the clip. Let me go back. After creating the fields, the one thing I need to do before I do the clip is I need to actually get the area of the way the census block groups are right now. I need to get their area and save that in area old. So I need to calculate geometry before I do the clip. So that's an area field. I'm going to use the coordinate system of the map. We're going to make that survey acres. Okay. Okay. All right. So now area old actually has values in it, like this is 230 acres, that's 82 acres or whatever. So each block group knows its original size. So, so now I can redo that clip. So I'm taking the census block groups, clipping them by the bomb radius, and the output is going to be, once again, the bomb population. And it warns me I'm overwriting it. It's okay. All right. So now that I've got that, I can open up that attribute table, scroll way over to the right. So this is the area that it originally was. Now I need to know what area is in, like, where it's got 1766. What is the area of that piece of a block group. So I can right mouse click and tell it, let's calculate geometry based on the shape it has now. So it's going to be area, and it's going to be in survey acres. All right, so this one, you see that one was 100% contained, 230, 230. So it's completely contained, whereas this one right here, only 24 acres out of the original 107, 24 out of 107 was actually kept. Okay, so what we need to know is the ratio of how much of the original census block group is in the output. So this one's going to be about 25%, 24 divided by 107. So what we want to do here is get the ratio by calculating this field. And I'm going to use VB script, not that it makes a whole lot of difference. And it's going to be the new area divided by the old area. Okay, so that'll be, if it's 25%, that'll give me a value of 0.25, right? Okay. Didn't refresh. Let me just reopen it here. So there it is. This one's totally contained, so it has 100% of the original. This one's got 99% of the original. This one has 22% of the original. See that? 24 divided by 106. 107 would be 0.228, whatever. Okay. So now we know what the ratio is of the amount of area between the new piece and the original piece. We can assume that the population for the area that's affected by the bomb is proportional to the area of the block group that we have inside, because we're assuming uniform or random distribution of the people. So for that to be calculated, I just say calculate field there, where I'm going to multiply the ratio times the original population, which is way up here. Total population. So now I know that here, for example, instead of whatever the original population is, I've only got 176 people instead of the original, whatever it was under, 107 acres. Okay. And then I can, map that. And when I do that, I get this. So you can see here, the original number of people in this block group was 1,036, but the number that are affected by the bomb is 944. This is entirely contained, so it's the same, 816. This one, there was the original value inside that block group was 695, but I'm only affecting the part right here, and then it is estimated to have only 479 people in it. So now I can sum that up. I can do right mouse click, summarize on that field and determine what's the total number of people that are affected. And that's easy enough to do if I right mouse click on that and tell it to let's see. I don't want to summarize, do I? There we go. Explore statistics tells me the sum of all people in there is 14,375. Okay. All right. Any questions about that? Again, if you're doing anything that involves like number of minority people around hazardous material sites, I'm expecting to see this process in your project. If I don't see this, I know you got the wrong number. You know, you need to have done this. Anything involving number of people around something or number of people affected by something, you have to have done this. All right, let's talk a little bit about this census data that's in the ArcGIS Pro project in the Orange County map here. So what we have is, I wanted to include this data from 2000 because even though it's 20 years old, it illustrates what the census tiger line files look like. You know, that you've got layers for all these geographic things like roads and rivers and lakes and places. And I wanted you to see what that looked like. You know, we see here, for example, we got the major roads, you know, being shown in red. We got the rivers there in blue. There's railroads, which are not very easy to see at this scale, but you can see a few of them right here. You got these big water features. All right. We got the urban area we talked about earlier. We have landmarks, which are things like what used to be called Herndon Airport and is now Orlando Executive Airport. So we got that. So those are all, you know, various parts of the census tiger line files. The metropolitan statistical area, that's actually a multi-county thing, so it's kind of boring for all counties in that. Here's the census places. And looks like the labels aren't turned on here. Oops. Okay, I thought I had those labeled, but all right, you could label those and see that that's Orlando, for example. You've got these CDC boundaries, which are not very helpful. Nobody ever uses those. The municipal civil divisions, again, nobody ever uses those. And then the actual county boundary is, you know, another part of the tiger geometry. So if we look at this slide, it shows you this naming convention. These are all tiger files for state 12, county number 95, which is Orange County. And then, you know, BLK, CCD, CDC, this all stands for the type of line file it is. And you can see that those are census blocks, civil divisions, congressional districts, and so on and so forth. So you might run into a naming convention like this, keeping in mind when you go to the census website, it's very hard to use. And to export census data, you can do it, but it's not very easy. Usually what you'll find yourself doing is downloading data from the state data depository where they've already converted it to shapefile format or geodatabase format for you. And it might use a naming convention kind of like this for the different layers. Now, when you've got the different census geographies like census tracts and blocks and block groups, as I mentioned earlier, the tabular data are usually not associated with them. Usually you have to join those. So here are the files, for example, that are for the county, the block groups, the census designated places, the state, which only has one record, you know, not very exciting, and the census tracts. And what you would do is you would join, now this is obviously not from ArcGIS Pro, but you get the idea. You would join the tabular data from your geometry layer, like this is for the block groups, to the attribute data in one of those tables, and they would have a field in common. In this case, it's called the STF ID. It's that FIPS code. But you can see the FIPS code goes all the way down to the census block group level and not beyond that. You got to make sure that you can only join the block group table with the block groups and the block table with the blocks. And the census tract table can only join to the census tracts. You can't mix and match them, okay? So you got to get the right table joined to the right geometry. So here we're joining the block group geometry to the block group data using the STF ID as the join field. Here are the definitions for the values that are in that older 2000 data. So you can see here the different kinds of tabular data that are already in the data set, from 2000. For Lab 7, we don't want you to use that old data. We want you to use something newer. So what we have in there is the Census American Community Survey data from 2022. So it's not even the census data. It's actually been updated in 2022. So we'll get to that in a minute. Before we do that, I want to talk a little bit about census and racial groups. When we look at the census data, let me go back out and look at that live census data again. We'll just go ahead and look at the actual Census American Community Survey here. So let me turn this other stuff off. We got, all this stuff, the name of the block group and all that. And then we have, the number of households, and then we have the number of males and females, and then we have the racial component. White, black, American Indian, or Eskimo. So that's basically all the Native Americans in one group. Hawaiian or Pacific Islanders. So that's, again, all the folks living either on the Hawaiian Islands or in the territories like Guam and those places that are American territories. And then we've got people who identify as something other than those. Multiracial groups. So if you consider yourself multiracial, you can say that in the census. And then Hispanic. We'll get to that in a minute. So some people have commented to me in the past, where like, why does it say black and not African American? Well, the census actually has looked at this over the years, and there's actually been a number of surveys done of African American people to ask them, what would you rather be called? And the results are discussed in some of these articles here. The Black Americans' preferred racial label. If you read that article, it's a article about this Gallup poll that's been conducted several times over the last few decades. And it shows you, here's the number of people that prefer to be called African American or Black, and the people for whom it doesn't matter. So it doesn't matter is the 64% say, I don't really care. Either one of those interchangeably works for me. And if you look at the number of people that prefer to be called Black and the number of people that prefer to be called African American, it's almost identical. So about, what's that, 36% of the population would like to be one or the other, but it's almost the same. And the number of people that want to be called either one of those and don't much care is like 2/3 of the population. It's a lot easier in the data structure to have Black as the name of the field. So the Census Bureau has just defaulted to that. But as you can see, it's not a bad choice based on the preferences that people have for what they want to call themselves. The census is very concerned about what people want to call themselves. So over the years, things like gender, it used to be just male and female, and now there's opportunities to put in other kinds of gender answers that didn't exist before. This word Hispanic, you have to be really careful of. First off, Hispanic is not a race. So you cannot add Hispanic to like white, Black, American Indian, Hawaiian Islander. You do not add Hispanic If you add Hispanic, you get more than 100% because Hispanic can be any race. Think about it. How many people in this group, raise your hands, know somebody who is Hispanic and Asian? You know anybody who's Filipino, Hispanic, and Asian? Okay. You know anybody who's Hispanic and Black? People from the Caribbean, Hispanic and Black. Many people from Latin America, Hispanic and Black. Okay. You know, how many people know white people who are Hispanic? Okay. Hispanic is not a race. Hispanic is an indication of your ancestry. Do you derive from people who had a last name from Spain? That's it. We also have a lot of confusion about the terms Hispanic and Latino. Now, in Florida, we tend to use these interchangeably because, you know, many of the people that we run into who are Hispanic are also Latino. They're from Latin America. That is not always the case. For example, people from Spain are quite definitely Hispanic, but they are not Latino because Latino means from Latin America. People from the Philippines are Hispanic, but they are not Latino. People from Brazil are Latino, but they are not Hispanic. Why not? Who can tell me why people from Brazil are not, most of them, not all of them. I mean, some of them are Hispanic, but most of them are not. Why? What's going on in Brazil? Yeah, Darla, can you shout it out or? Okay, Emily says, yeah, they're Portuguese. Brazil was a Portuguese colony. So a lot of the people, again, you know, there's been migration over the last couple of hundred years. Most of the people who live there, though, are native speakers of Portuguese. Their naming convention is from families that were originally from Portugal. They are not derived from Spain, but they're from Latin America, so they are Latino. They are not Hispanic. People from Venezuela are both Hispanic because they were derived from Spain and Latino because they're in South America. All right. So you have to be careful. This is a Venn diagram. There's folks that are Latino. There are folks Hispanic. There are some folks that are both Hispanic and Latino, but those two terms are not synonymous. You can be in this group that's either Latino and not Hispanic or Hispanic and not Latino. There's only a certain group of countries that are both Hispanic and Latino. Okay. Any questions about that? The key thing to remember is it's not a race, so you cannot add it to white, black, Asian, because if you do, you'll get more than 100%. You can say Hispanic and non-Hispanic, but you can't add it. So Hispanic is an ethnicity. It indicates whether or not you're derived from Spanish-speaking people. And here's the breakdown by race. Some 53% of all Hispanics are, you know, identify their race as white. This is also a chance here to talk about this term, Latinx. How many people are familiar with the term Latinx? How many people routinely use Latinx? Yes, we're worried about the Latinx community. If only more people from the Latinx community would show up. What are we going to do for outreach to the Latinx community? Nobody here is going to admit to using that? Okay. Good thing. Because it's a terrible, in my view, it is a terrible thing that's been adopted by people that look like me, okay? White people who have this misguided idea that if we're going to be gender neutral, that we need a gender neutral word to refer to both male people who are Latino and females who we talk to as about individually as being Latina. She is a Latina. He is a Latino. But you know what? Spanish, the language, is not, it's unlike English, it's actually gendered. All the Romance languages are Spanish, French. If you talk to anybody who's a native Spanish speaker, you know, you would ask, well, how do you refer to an individual male person who's from Latin America? He is a Latino. She is a Latina. How about all of you collectively? We are all Latino. The collective is using the masculine form of the word, Latino. And they're fine with that because that is the way Spanish works. Latinx is an attempt by people who look like me, white guys, trying to apply what they think is a gender neutral term to another culture. And it's pretty terrible. If you actually ask people, if you ask Latinos, what do you think of the word Latinx? Most of them have never heard of it. 76% have never even heard the term. Of those that have heard of it, 20% of those, most of those who have heard of it, 20% of the total population, but most of those that have heard the term don't like it. They don't use it. There's only 3% of the Latino community that actually use Latinx. And please, please do not use Latin X. I've heard that on the radio. And it's like, I want to just crawl into a hole and die when I hear that. That is just awful. But even Latinx is there's no reason for it. Latino people refer to themselves as Latino. And this article, if you follow the link here, gives you a big breakdown from that poll of how Latino people like to refer to themselves. So Latinx should not be used to describe Hispanic people. 65% of all Latinos agree with that. All right, so let's talk about where we can get some census data. In this case, for Florida, other states, will have their own GIS data depositories. And like I said, usually it's easier to get your census data from a state depository where they've already converted it. If you go directly to the Census Bureau, I'm not even going to bother to show you that. It is so difficult to use their website. I mean, it's possible. I've used it, but it is not very user-friendly. It does not have just layers for you to download. Basically, what it has to do is it creates every data layer on demand. You go and tell it what you want, and it creates it for you on request. So it does not have just layers to download. Every time you want a data layer, you have to tell it to make it for you. It's very weird. If we go to the Florida Geographic Data Library, and that's the link for it here. Let me go ahead and go to that live. You don't want to use this Explorer because this is terrible. That they redesigned the website and this thing doesn't work at all. I would not use that. You want to come down to where it says the current data catalog and click on that. And here you can search for anything you want. So if you were looking for soils data, you could enter that, but we're looking for census data. So we're going to clear that. And we're going to tell it census. And I can see amongst the most recent data, it's currently sorted by source date, is this Cenax 2022 data. All right. So if I download that, I can use that. That's going to have census data that's, the latest available, basically. Clicking on this metadata link takes you out to the metadata page, which has an explanation of all the data fields. Once it actually shows up. Hello, there it is. So you can see here, acres, state, county, tract, block group, number of whites, number of blacks, number of American Eskimos, so on and so forth. So there's all the fields, okay? So if you need to figure out what a field is and it's not clear to you from its name, you can go to that metadata page and look it up. Here is a list of the data field definitions from 2015. Some of these have changed, so you might not, like I know, for example, the land area, it no longer is named A land 10, it's named just A land, so that's a little different. But these are still, I think, mostly being used in 2022. But anything you don't find on this list, go out to that metadata that we just looked at. And here's another link to it right here. So let's take a moment and look at the census data that's in the Cenax 2022 data for Orange County. I've also given you the layer for the entire state of Florida if you're interested in looking at that later. But Lab 7 is going to be only for Orange County. So we'll go ahead and take a look at that. Right by default, it's got the landscape is symbolized according to median household income. And if I was to create a map based on this area, which is what you're going to be doing in Lab 7, you cannot make a map of the entire county in Lab 7. That is verboten. Okay, let me say that again. If you turn in a lab that is all of Orange County, you're going to lose points. You have to find an area of interest somewhere, the UCF area, the Winter Park area, the Windermere area, the area around the Paramore district around the arena. You know, you have to find an area of interest somewhere in the county and make a map about that and its demographics. So here, I might have given the map that I would make out of this. Income differences across the I-4 divide in downtown Orlando. You can see that on one side of I-4, people do not make very much money. And on the other side of I-4, they make quite a bit of money. Okay, so here, I've taken the same data and I've symbolized it according to percent Black. And so I've got this neighborhood over here. This is the Paramore district. And this is Pine Hills up here. So these areas to the west of I-4 have very high percent Black populations. If you walked around, you know, the number of Black people you meet, there'd be like 61 out of every 100 people would be Black. Whereas over on this side of I-4, you know, it tends to be pretty lily white. Not always. There's some neighborhoods that have got more Black people in them, but a lot of them are going to be down here in the 8% or less Black people. And if I were to make a map of that, I might call that something like racial differences across the I-4 divide. Now, again, don't turn in a map that says racial differences across the I-4 divide in Orlando, because, you know, you just copied the one I did. Don't do that. Here's another map that is using what we call a bivariate colors symbology. And what that allows you to do is look at two variables at the same time. So I've normalized Blacks by the population to get percent Black. And I haven't had to normalize median income because it doesn't require normalization. So I have percent Black and median income. And if I look, those areas that are increasingly Black go from light to dark blue. And those areas that are increasingly well off, that have a high median income, go for light to dark red. So that's light to dark red. So the areas that are high in the percentage Black and high in income would be this really dark purple color. Areas that are high for percent Black but low income would be this blue color. And there's quite a bit of that. So these are areas that are both Black and low income, seen on one map. And I might call this the relationship between race and income across the I-4 divide, you know. Okay, so your assignment for Lab 7 is pick an area of interest within Orange County. Do not make a map of the entire county. You might have to decide, am I going to do a landscape or portrait? That kind of depends on, you know, the shape and size of your area. Do you need to normalize your data? Maybe, maybe not. Kind of depends on if you're dealing with counts and you want to do it like divide through by population, or divide through by, if you've got something like vacant housing units, you could divide through by the total number of housing units to get percent vacant. But make sure your normalization makes sense. If you divide one number by another number and it doesn't make any sense, points off. You know, so normalizing data using two unrelated fields like Black and median. If you were trying to divide Black by median household income, that doesn't make any sense. blacks per median income, blacks per dollar, that doesn't make any sense. So that would be points off. You need to normalize, or I'm sorry, symbolize your data in a way that makes sense, like we've talked about. Usually a single hue color scheme, light to dark, is what you're going to want. But you could use the bivariate symbology if you want to deal with two variables simultaneously. You need to give your map a meaningful title. So you cannot call it Lab 7. You cannot call it Census Map. It's got to be meaningful. You saw the examples I gave you, right? Based on what it is you're trying to tell a story, based on the story you're trying to tell about the area you find. Is it about single mothers in the UCF area? Is it about poor families in the UCF area? Is it about, poor families living in Winter Park? Whatever it is, you need to come up with a title that tells the reader what is the story you're trying to tell with your map. Export the whole thing to PDF and upload it to this assignment. So if we just look at the data again, we went through those slides, but I just want to, take a look at it live for you here for a moment. So if I zoom in on an area, let's zoom in on, for example, like the UCF area. One of the things you'll notice here, the UCF area has no income data. Neither does this area. There's a number of areas that are redacted, and that's because there's too few people living there, or some other reason why they had to redact those areas. Okay, I don't know why UCF is redacted, because there's obviously a lot of people living on campus. It may well be because the number of people that are filling out the census, they're all filling them out at home and not on the campus. And it ends up being a total population of less than, whatever it is, 100 people. But if I look at incomes, there are some holes, but, I can see there's good income data, over here. If I wanted to look at something else, I could look at, instead of income, I could do graduated colors based on, maybe the number of Hispanic people. And find that again. As a proportion of the total population. So this is percent Hispanic. Right now I'm doing natural breaks with 10 groups. I could do quantile with 10 groups, okay? And I can then format these, instead of as decimals, I can format the labels, instead of as numeric, as a percentage, and tell it the number is currently a fraction, adjust it to show a percentage, and now it shows it as a percentage. And I can do, instead of 6 decimal places, I can do maybe 3 or 2. 2 looks good. Okay, so now I've got percent Hispanic, and I can change this to percent Hispanic. And maybe use a different color scheme. If I don't like that one, I can use, I don't know, maybe that one. Okay. And the bivariate one, pretty easy to do. You could see it in the slides, but just to illustrate it, if I wanted to do bivariate colors, I just need to pick 2 variables. So say I wanted to do, I don't know, the percent Asian. So we're going to take Asian divided by total population. So that gives me percent Asian. And then for the second field, let's do median household income. Okay. So where there's like lots of Asians that are making a lot of money, they would be this dark purple color. And where there's very few Asians and they're not making very much money, that would be this light color. And then you've got everything in between. And you can change the color scheme. If you don't like that one, you can pick, other combinations, like maybe that.